gases. So gases are just a phase. We're describing a phase of matter and the way that gases behave. And there's a general set of definitions for gases called kinetic molecular theory. And it has 5 parts. The first part, gases consist of small particles compared to the size of their container or their volume. Number 2, gas particles move randomly at high velocities. Number 3, gas particles are not attracted to one another. The intermolecular forces between gases are low. Gas particles move constantly in straight line motion and the last one we've talked about before, the kinetic energy of gas particles is proportional to their Kelvin temperature. Okay, so let's just talk about these real quick. Gases consist of small particles compared to the size of the volume that they are taking up. So you have a volume of gas, a certain amount of gas. The size of the particle is very small compared to that whole volume. Gases occupy a large amount of space, but the particles themselves are very, very tiny. Gas particles move randomly at high velocities. Once we see a gas particle, we cannot predict where it will go next. All we know is they're moving randomly in all directions. Number 3, gas particles are not attracted to one another. Intermolecular forces between gases are very small. We don't see them attracting each other. If they did, they'd start to turn into a liquid. Number 4, gas particles move constantly. They don't stop moving, and they move in straight line motion. They collide with the walls of their container. And then number 5, the kinetic energy, which is 1/2 mv squared, is proportional to the Kelvin temperature. We talked about this when we talked about heat and energy. Kelvin has a special thing. 0 Kelvin is absolute zero. And absolute zero is where the particles stop moving. If the particles stop moving, They have no kinetic energy, and therefore they're 0 Kelvin. No motion, no temperature. As the temperature goes up, that means the kinetic energy is going up. Higher kinetic energy, faster particles, higher Kelvin temperature. That's going to be very important in this unit. And in this unit, the only temperature we will use is Kelvin. Everything must be in Kelvin when we're dealing with gases. Questions so far? Okay. Ways that we describe gases. We describe their pressure. And this is the force of the particles on the container walls. When gas particles collide with something, those collisions create pressure. It's the gas particles pushing on the walls of the container. We measure pressure in 3 units: atmospheres, millimeters of mercury, and torr. This atmosphere comes from the idea that on Earth, our atmosphere is made of gases. Those gases push on Earth with pressure, and the pressure of the whole atmosphere is 1 atmosphere, 1 atm. Now, that changes with the weather. The pressure on a good weather day can be lower or higher. Usually low pressure systems are bad weather, storms. High pressure systems are sunny and nice. But regardless, pressure of the atmosphere is 1 atmosphere, the whole entire 1 atmosphere. And we just use that to compare pressures of things. Questions about that? Okay. We also describe the volume of a gas, the space that it occupies. This could be in liters, milliliters, centimeters cubed. It's a volume. We describe the temperature of gas, which is, it's telling us the speed of the particles, average kinetic energy of the particles. And it must be in Kelvin. Just a reminder, the temperature in Kelvin is equal to the temperature in Celsius plus 273. 1 degree Celsius is 274 Kelvin. 0 0 degrees Celsius. The freezing point of water is 273 Kelvin. 0 Kelvin means zero motion. And that's negative 273 degrees Celsius. It's very, very cold. And then the last thing is the number of moles of gas. The amount of gas. In moles. And you might use the molar mass to find that if you know the grams. Questions about this? Okay, one more thing I want to talk about, the atmospheric pressure idea. So, when we're talking about atmospheric pressure, the atmosphere is made of gas, nitrogen, oxygen, carbon dioxide, other random gases that we don't talk as much about. But regardless, all those gases are in motion, and they're constantly colliding with the surface of Earth and with the objects on the surface of Earth. So when you're sitting in your chair, there is pressure from the atmosphere pushing on you all the time. And your body has become accustomed to that pressure. Which is why if you drive through the mountains in Colorado, as you go up the mountain, your ears pop. What happens to the pressure as you're driving up the mountain? It's going up or down? It's going down. Because as you go up the mountain, there's less pressure pushing on you. There's less atmosphere up there. So there's less pressure. Because there's less pressure pushing on you, your body doesn't know how to deal with that. It continues pushing out as much as it was when you were at the base of the mountain, and your eardrums go out. That's that popping feeling. Same thing as you go up in an airplane. Your ears pop. Inversely, as you go down, if you drove into the bottom of the Grand Canyon, your ears would pop. But that's because the pressure is going up. There's more atmosphere pushing on you down there. And the pressure outside is more than the pressure inside you. And your eardrums go in. And you feel that popping. Same thing as you land on an airplane, if you've ever felt that. This all has to do with pressure and the atmosphere. And it's going to determine things like baking times. So, if you've ever looked at the box of brownies, there are different instructions for high altitude baking. Because the pressure is less up there, so it either takes one of two things, less time or a lower temperature to get your brownies to bake because the atmosphere is not pushing on it as much. Water boils at a lower temperature on the top of a mountain because the atmosphere is not pushing on it as much. If you tried to bake brownies in the bottom of the Grand Canyon, you would either have to bake them longer or you would have to bake them at a higher temperature because there's more pressure pushing on it. Does this kind of make sense to you? The atmosphere produces pressure. Our bodies are accustomed to that pressure. When we change it, when we go up in the mountains or up in an airplane or down in the valley, we feel that. We can feel the changes.